This episode of 365 Days of Astronomy is sponsored by Adrian Morgan, in honor of my favorite episodes from previous years. These include August 15th, 2009, January 11th, 2010, and December 27th, 2010. Find Adrian at Outer Hoard, that's outerhoard.wordpress.com, and at Gold Hoarder on Twitter.
You are listening to the 365 Days of Astronomy podcast. Year 3! Enough with the theme. Let's get to it, shall we? The 365 Days of Astronomy podcast starts now.
Hi, I'm Emily Lakdawala from the Planetary Society, and I'm here to tell you about what an exciting year 2011 is shaping up to be in solar system exploration. In fact, I'd argue that we're in the middle of the greatest age ever in planetary exploration. Did you know that there's more than 20 spacecraft out there exploring our solar system? They're at Venus, the Moon, Mars, and Saturn. They're on their way to Mercury, asteroids, comets, and dwarf planets. And there's 4 more scheduled for launch later this year. The 3 events that I'm most looking forward to in 2011 are encounters with a comet, the smallest planet, and one of the biggest asteroids. The first big event will be Stardust flyby of Comet Tempel 1 on Valentine's Day. That's February 14th. Stardust is a spacecraft that has a second lease on life. It launched 12 years ago to fly past Comet Wild 2, where it gathered particles from the comet's tail in a sample return capsule. Stardust returned its capsule to Earth 5 years ago, but it continued on its own orbit around the Sun. Now Stardust is going on to a second comet, the one that was smashed into by Deep Impact in 2005. Deep Impact left some unfinished business at Tempel 1. It successfully smashed an impactor into the comet, and it took lots of pictures and other data. But Deep Impact's crash tossed up so much dust that the spacecraft never saw the crater that it created there. Now Tempel 1 has completed an orbit around the Sun, passing through its perihelion, and Stardust is going back there for a second look. Hopefully, Stardust will finally get the picture of the Deep Impact crater that we've been waiting for, and maybe it'll see some changes on the comet's nucleus in the nearly 6 years that have passed since Deep Impact flew past. But because the rotation rate of the comet nucleus isn't totally precisely known, there's actually a chance that Stardust will not get to see the right side of the comet to solve the mystery of the crater diameter. But if that happens, there will be a silver lining. Stardust will image the half of the comet that Deep Impact never saw. The next main event for 2011 will be at the smallest planet, Mercury, which will finally earn its first orbiter. Considering how close it is to Earth, it's just amazing that Mercury hasn't had a dedicated orbiter yet. It's just hard to get into orbit at Mercury because it's such a small planet located so very close to the massive Sun. So it's taken more than 6 years for Messenger to get there, and it'll enter orbit on March 18th. Messenger needed 1 flyby of Earth, 2 of Venus, and 3 of Mercury to help adjust its orbit to one that nearly matches Mercury's. During the 3 Mercury flybys, which happened in 2008 and 2009, Messenger did manage to snap pictures of most of the planet, but the orbital mission will give Messenger a chance to make uniform maps of Mercury. It'll also map the planet's topography for the first time, map the composition of its surface rocks, map its magnetic field, and study the atmosphere. Yes, Mercury actually does have an atmosphere, but it's so thin that atoms in the atmosphere almost never bump into each other. The atmosphere is made mostly of ions that are blasted off of Mercury's surface by the solar wind, so in a way, studying the atmosphere actually lets us study the composition of the surface. But the event that I'm most looking forward to happens this summer, when the Dawn spacecraft arrives at Vesta. Arrival is not exactly the right word. It's not like most orbital missions where there's a death-defying orbital insertion maneuver and mad thruster firings to quickly break the spacecraft into orbit. Vesta is a small world without much gravity, so that wouldn't work. Vesta is only about 500 kilometers in diameter, about the same size as Saturn's moon Enceladus. That's less than 1/6 the diameter of our own moon. So instead of depending on one big rocket firing, Dawn's been working on matching its orbit with Vesta. It'll slowly creep up on the asteroid throughout July. The exact arrival date is a little uncertain because it depends in part on how well Dawn's ion thrusters perform. Sometime in late July, Dawn will gently slip into orbit around Vesta and continue spiraling downward. Its first orbit will take 10 days. The second orbit will take 4 days. By the time it gets within 2,700 kilometers above Vesta, it'll be in a 3-day orbit and it'll stop descending for about 3 weeks while it maps Vesta from a distance. Then it'll go down even farther, orbiting faster and faster and getting higher resolution images and spectra. Once Dawn is in its low-altitude mapping orbit, about 180 kilometers above the surface, it'll be close enough to Vesta for lumps and bumps in Vesta's shape to cause the spacecraft's orbit to have lumps and bumps that'll be measurable through the Doppler shifting of its radio signal with Earth. Dawn's going to spend a full year at Vesta before departing for its journey to the biggest asteroid, Ceres, in July 2012. After Dawn gets to Vesta in July, we're going to enter launch season. There isn't usually a specific season when planetary launches happen, but for some reason in 2011, all the major launches are clustered together on the calendar, which must be a big headache for NASA. First up is Juno, which will launch for Jupiter in August. Juno is designed to study the atmosphere and the interior of Jupiter, answering big questions about the biggest planet's composition, the size of its core, and the origin of its magnetic field, among other things. None of these mission objectives really needs a camera, but don't worry, Juno's going to have a small color camera called JunoCam that's been included on the mission primarily because no one could bear to send a spacecraft all the way to Jupiter without putting a camera on it. But it's going to take a while for Juno to get to Jupiter. After its launch, it spends its first 2 years in the inner solar system. Then it has a gravity assist flyby of Earth in 2013, and it'll go on to arrive at Jupiter in 2016. After Juno launches comes Grail. Scheduled to launch in September, Grail is actually a pair of spacecraft that'll orbit the Moon in tandem. Once they arrive in orbit in January 2012, they'll use highly precise radio signals transmitted and received between the two spacecraft and Earth to map the gravity field of the Moon, which will tell us about the distribution of mass in the Moon's interior. This is an experiment that's actually been performed before by Japan's Kaguya mission and its 2 mini-satellites. But Grail's map will have twice the map resolution of Kaguya's, and what's more, it'll be 100 times more precise. Finally, late in 2011, there will be 2 launches to Mars carrying 3 spacecraft. Mars launch opportunities come once every 26 months. The last one was in fall of 2009. There were 2 launches that were supposed to happen then, but neither spacecraft was ready at the time, so both of their launch dates had to slip the full 26 months. One of the 2011 Mars launches will be NASA's next big rover. The rover has been named Curiosity by NASA, but most scientists will probably continue to refer to it by its acronym, MSL, which stands for Mars Science Laboratory, although it used to stand for Mars Smart Lander. I hate acronyms, so I'll be sticking to call it Curiosity. Curiosity is much, much larger than the Mars exploration rovers Spirit and Opportunity. The enormous size is because it's carrying a much, much bigger science package than Spirit and Opportunity did. Basically, Curiosity has the kind of capable analytical chemical lab on board that has so far only been put down on landers, not mobile rovers. NASA hasn't picked Curiosity's landing site yet, but it's going to go to some place on Mars where there is liquid water for a long enough period of time to produce an environment that might once have been habitable for past organisms. NASA is very careful to say that Curiosity is not looking for life on Mars, and it's not even really looking for fossils. It's just looking for evidence for the past existence of the kind of environment that might once have supported life. This is all a little bit lawyerly, but a key fact is that the landing site, whatever it is, should wind up having more spectacular scenery than Spirit and Opportunity had when they landed, because Curiosity's landing system permits a more precise landing in the midst of a bit more interesting terrain. However, like Spirit and Opportunity, Curiosity will probably have some long, slow driving to do before it gets to the really interesting stuff. The other Mars launch in 2011 will be Russia's Phobos sample return mission, formerly known as Phobos Grunt. Grunt means soil or ground in Russian. Apparently, my former boss, Lou Friedman, clued the Russians in that Grunt sounds a little odd in English, and so now they're calling it Phobos sample return or PHSRM instead, which makes me kind of sad. Anyway, Phobos Grunt will launch to Mars, nudge into an orbit that follows Mars's moon Phobos, and study Mars and its moons for a little while. Then the whole spacecraft will set down onto Phobos, take a sample of the soil, pack it into a capsule, and then fire a small sample return spacecraft back to Earth. A Chinese orbiter called Yinghuo-1 will hitch a ride to Mars aboard Phobos Grunt. Once it's there, it'll study Mars's atmosphere. Yinghuo-1 will also have an orbit that'll enable it to take good pictures of Deimos. In fact, it may have the best chance since Viking to take pictures of that moon. Another stowaway on Phobos Grunt is a small experiment provided by the Planetary Society called Phobos Life. Life is a hockey puck-sized chamber deep within the sample return capsule that'll carry microorganisms to Mars and back. Once Phobos Grunt sample capsule is received back on Earth, biologists will examine the life organisms to see if they've suffered any damage from the years spent in space. You can learn more about life on our website at planetary.org. So that's all the big new stuff that's happening in 2011. Meanwhile, there's already lots of other activity in space that'll continue throughout the year. Europe has 2 spacecraft at Venus and Mars named Venus Express and Mars Express. The Moon has 2 orbiters, NASA's Lunar Reconnaissance Orbiter and China's Chang'e 2. Mars has 2 other orbiters, Mars Odyssey and Mars Reconnaissance Orbiter. The Opportunity rover is still rolling across Mars, and hopefully we'll hear again from a hibernating Spirit this year. The Cassini orbiter has just won a 7-year mission extension at Saturn, and will have close flybys of Enceladus, Rhea, and Dione this year. And apart from all of those, there are lots of other ships cruising from place to place, like Europe's Rosetta Comet mission and NASA's New Horizons Pluto mission. And then there's always the 2 Voyagers, which are venturing out beyond the solar system into interstellar space. It's going to be a great year, and I'll write about all of these missions and post lots of beautiful images at planetary.org/blog. This has been Emily Lakdawalla for the Planetary Society blog. Thanks for listening.
You are listening to the IYA 365 Days of Astronomy podcast. Cool.
The 365 Days of Astronomy podcast is produced by Astrosphere New Media Association. Audio post-production by Preston Gibson. Bandwidth donated by Libsyn.com and Wizard Media. Web design by Clockwork Active Media Systems. You may reproduce and distribute this audio for non-commercial purposes. Please consider supporting the podcast with a few dollars or euros. Visit us on the web at 365daysofastronomy.org or email us at info@365daysofastronomy.org. Until tomorrow, goodbye.